All right, those command injection vulnerabilities are pretty spectacular when they happen, but they're not that common. This is what's far more common, SQL injection. Something like 10% of websites have this vulnerability. At least they used to, and I don't think it's improved much lately. So here's what, just so you get used to SQL, the problem here is SQL injection is essentially the same. You get to execute arbitrary commands on the server, but you don't get to execute command line commands like bash. You can only execute commands in this language called SQL, which is not as familiar to people. So in SQL, you can select things. And this is the pain that the administrator would have. You would never let a customer have this. So you can just select one, and then the answer is one, as you might imagine. But you can show databases. And you'll see what kind of data is stored in your SQL server. And so it'll show you that I have one thing called information schema and one thing called widgets. Now, the reason you can, in order to do SQL injection, you have to ask for the data you want. So you have to know the name of the field and the name of the table and the name of the database. And that might be difficult, except for the fact that SQL uses its own structure to store the metadata. So it automatically creates some tables that always have the same name that include the information you need. And this is MySQL, so it uses this information schema table, which always has the same name, and it contains all the information you need. So if you want to find all the tables in the database, you can select table name from information schema tables. And then you'll see all the table names. And you see there's a lot of capitalized table names, which are automatically generated by the software. And then way at the bottom, the only one that actually was generated for the use of this company called employees. So if you're trying to find stuff like credit card numbers and such, that would be the one to look in. And you can also find all the columns in the database from information schema columns. So that's the sort of thing you do to track down what the names are of the tables and the columns. So there's a table called employees, and there are columns ID, name, and SSN. So that means I could steal all the data pretty easily in this form with select star everything from employees. Should probably be all I need to do, the name of the table. And now I get everybody's names and social security numbers in my database. So you can do other things. You can concatenate together strings. You can pick certain characters out of strings, and we're going to need those later. But this gives you the same as that other one showed you, like the top 10 bash commands. Now you know a few SQL commands. And so now you have some flags to find here. In this section 1, you use that query to find some things, which should be pretty easy because you have the same power as an administrator. Now, of course, this would not be a security problem this way because you only let the administrator have that table. In the section 2, there's a separate server in each section, so don't try using the flags from one section in the other section or it won't work. So here, this is what you really let a user have. They can just put in a name and it searches for the name. So if I search for Fred, it says, no results, there is nobody named Fred, and it shows you the query it's executing. The developer wrote all this code. I only gave it the name Fred, and then the developer put in this apostrophe. So I don't have control of the whole select statement. I only have control of the little part inside there. And since they didn't filter out special characters, like apostrophes, that means I end up getting full control of the system anyway. Because of this, if I put in a name with an apostrophe, like Tip O'Neill, then I get a syntax error. This is the kiss of death. If you see a syntax error, what that means is the apostrophe that I put in matched an apostrophe that the developer put in, and now this part is interpreted as active code. So the developer has lost control of their program, and now I have the ability to execute code on the server. Now it crashes because this is not a valid SQL command, but now it's just up to me to, instead of just putting in a name with one apostrophe, to put in a more carefully crafted injection that will remain valid and be executable. So here's one that will do it. If I put in this sequence of special characters, Then I get all the names because it selects name from employees where name equals Sam. This completes that string, and then I have or 1 equals 1, and then I have pound, which is a comment line, so it ignores that apostrophe. So it doesn't have an unmatched apostrophe, which was the syntax error. It has a compound conditional, where it's either this or that, and the second one is always true, so I get all the data. And so now you can execute various things, and now I can turn this form into the other form with this technique. I can use union to add a second query. So now it looked for Sam and there was no Sam, but then it looked for 1, and of course it found 1, so the result is 1. So now I can add my own select statement of any type I want. The only rule is I can only have one result because it's adding it in a column with the other results, and there's only one column here for names. But other than that, I now have been able to make an arbitrary select injection here where I was only supposed to be able to put in a name. And so there are some flags to find. Now, the real pros typically use SQL Map, so you can install SQL Map on any Linux server and practice using it on a couple of these targets and find some flags. And it's just an automated tool to do this for you. And then there's blind SQL, which is a lot of fun. Blind SQL is, in my experience, more common. This is where the server is vulnerable, but it doesn't just show you the results. So here, if I search for Bill Gates, then it finds Bill Gates. Okay, that's not surprising. But if I search for X, somebody that does not exist, it shows me no result. Well, that's also not too surprising. But if I put in an injection like this one, then what happens is I've now made a valid statement where name equals X or A equals A. And instead of using a pound character as a comment, I just carefully crafted it with a missing apostrophe in what I added. So the apostrophes from the developer added to this will create a valid statement. And it found something. It should have returned all the data in the database, but instead it just said user found, and it repeated my injection. So this is not printing any data from the database. It's just printing data that came from you. And if it finds it, it repeats what you said, not what it found in the database. That's why they call it blind. I have no ability to directly see any data in the database. And yet I can still find everything out because if this condition, A equals A is true, and when it's true, I see something found. If I make that condition false, like A equals B, then I get no result. So I get one bit of data. I can ask a yes or no question, and I will get the answer. So, just like the game 20 questions, you can slowly piece out data. So you can find out the length of the database. So here, for example, is a command that will check to see the length of the database is 1. The length of the name of the database. And it is not 1, so I get a result, no result. But I could see if it's greater than 1. And then I'll get a result. So by trying various values, you can narrow it down, find out the length of the database. And since you can substring, pick out one character, you can take one character and compare it to other letters and zero in your way and find things. So you can find social security numbers, IDs, and everything as you go on. You can piece out all these things. That's called blind SQL injection, and it's the most common case. So there's a few of them to solve. I'm going to stop this and post it.